So in this question here, we've got a function f of x equals 2x cubed plus 11x squared plus 12x minus 9. And we've got two questions regarding this function. We want to show 2x minus 1 is a factor of f of x. And we also want to show that f of x equals 0 has exactly two solutions. Okay, so let's go for part A first. So we want to show 2x minus 1 is a factor of our function. Now, for 2x minus 1 to be a factor, we need to have 2x minus 1 to be equal to 0. So now if we solve for x, so we'll have 2x equals 1, therefore x equals a half. Now, if we plug in a half into this, we should be able to set it to 0. So let's test that. And then when we've done that, if that is correct, we have shown that 2x minus 1 is a factor of the function. So let f of 1 half equals 2 times a half cubed plus 11 times a half squared plus 12 times a half and minus 9. And hopefully this will come to 0. So let's do our calculations on this. So 2 times a half cubed, well 2 cubed is 8, so that is 1/8. So 2 times 1/8 plus 11 times half squared, well 2 squared is 4, so that's going to be 11 times a quarter. And then add 12 times a half minus 9. Okay, now let's simplify all these up. So 2 times an eighth, that becomes 2 over 8. So that becomes a quarter. So we'll simplify up in a moment. 11 times a quarter is 11 over 4. 12 times a half is 12 over 2 and minus 9. Okay, so now let's simplify up. So quarter. We've got quarters here as well, so we'll leave that as 11 quarters. And here we've got 12 over 2. Let's write that as 24 over 4. So we've got same denominators. And then minus 9. I'm going to leave that as it is. So for this to be equal to 0, I've got minus 9 here. So I'll leave that. And therefore all of these should then also add up to plus 9. So let's see what happens. 24 plus 11 is 35, plus 1 is 36. So that's 36 over 4, which equals 9. So therefore that equals 0. So therefore we've shown 2x minus 1 is a factor of f of x. So we've done that. That's all good. Okay, let's clear the board and let's show that f of x equals 0 has exactly two solutions. Okay, so now f of x equals 0 has exactly two solutions. So let's have a look at that. So we've got f of x equals 0. Now we know 2x minus 1 is a factor, but we need to factor out all of this polynomial on the top here. So we've got f of x equals 2x minus 1 plus some function g of x, which is factored out from there. So how are we going to find what that is? Well, there's a few ways. One way I'm going to show today is using synthetic division. So synthetic division, we have to do a little bit of a setup. So we set up a table with our polynomial x terms and constants on the top. So this one goes up to x cubed. So I've got x cubed, I've got x squared, I've got x and c for my constant. And then what I write in here is the coefficient for each of these. So x cubed has got a 2, x squared has got 11, x has got a 12, and my constant has a minus 9. Okay, so now I need to leave a little gap here. So I need to write some numbers in there. And this here will be my remainders. So this here is something I use for my calculations. This here will be the result of our g of x. So if I write g of x here, that's what we're trying to calculate. Now I know that 1 of my function. So 1/2 will go here. So let's put a little box in this bit here. Okay, now what I do now with this 2, I write a 0 here. Okay, so now what I want is add these along to get my remainder. So I'll put a little plus sign there. So 2 plus 0 is 2. Now the reason I put a 0 in there is because if I take 2x minus 1 out of this, there's going to be no more x cubed. There will only be x squared as my highest order of polynomial. So I'll put a 0 in there, and then what I do now, 2 plus 0 is 2. So now half times 2, that gives me 1. So I'll write my 1 in this column here with my x squared. Okay, now I add these on as I did in this column to give me my remainder, which is 12. Now I do half times 12. So a half times 12 gives me 6. Okay, now for my remainder, 12 plus 6, that gives me 18. Okay, so now with this 18, as I did with these two, 18 times a half gives me 9. So I'll put that in there. And then I need to know if this is exactly factored out. I'll do minus 9 plus 9 to give me 0. If I get a 0 here, then we are done with our calculations. So that's all good. So that's good. So that's a good tick. So now what I've got here, 1, 6 and 9 underneath here, that is the result of my g of x. So therefore my g of x equals x squared, 6x, and it's a positive, and also a 9 for my constant, which is also positive. Okay, so that's what I've got now. So now I can rewrite my f of x as 2x minus 1 and x squared plus 6x plus 9. Okay, so now we've got this into some sort of form that maybe we can work with. Now we still haven't shown that it's got exactly 2 solutions. We know this one gives us a half, but now we need to see what this one gives us. So if we set this to be equal to 0, that will show us our solutions. So if we set that to 0, we can ignore that for the moment. We've got that sorted. Now we need to try and factor out or solve this one for x squared plus 6x plus 9 equals 0. So let's rewrite that on this line here. So that's my g of x. X squared plus 6x plus 9 equals 0. Now I need to factor out this or solve it somehow. Now I've got 9 here. So for my constants in my brackets, let's get them ready. I need 2 numbers here for my constants, which when multiplied together give me positive 9. So I've got 3 options for that. I've got 1, a 3 or a 9. They're my factors of 9. So I can have 1 and 9 together, or I can have a 3 and a 3. Now for this plus 6x, I need 2 numbers which when added together or subtracted give me 6. Well, I know a 1 and a 9, that's never going to yield a 6. So they are out. But 3 plus 3 gives me 6. So I'm going to write this as x plus 3, x plus 3. And that will give me my factoring out of this polynomial g of x. So now let's go back to f of x. So therefore f of x equals 2x minus 1, x plus 3, x plus 3. Now I could write that as x plus 3 squared if I like, but I'm just going to show that these are the same factor. So now solving for x plus 3. So if I've got x plus 3 equals 0, x equals minus 3. And as will be that one as well. Now they will be my only solutions. So I've got x equals minus 3 and x equals a half. So that would be my only 2 solutions for my f of x. And that'd be a good place for us to stop.